I know that I've said we're going to continue factoring. Like, there will be a little bit of factoring on your next test. There will be other things as well. It's not going to be all factoring. But there's going to be factoring in this unit, yes? So we're only doing factoring for a couple days, and then we're going to move on to other methods, okay? But then in our next unit, there are also different reasons that we're factoring, yes? So just know that it's not going away. So yes, we're only doing it for a couple days in this unit, but it's still not gone, yes? It will come back. It's just my warning sign right there. Yes? Okay. Okay, solving quadratics by factoring, it's the zero factor property, which I will explain what that means here in just a second. Okay, it says the solution to a quadratic equation is the x value of the x, sorry, it's like the corner, x-intercept. So the x value of the x-intercept. In order to find an x-intercept, you let y equals 0, and then you solve for x. Try not to like call you out on the video. Okay, so solutions, x-intercepts, roots, and zeros, those all mean the same thing. That's why there is equal signs in the middle, because they're all the same, yes? So if I say what's the root, that's the same thing as saying what's the x-intercept, which is the same thing as saying what's the zero, yes? Does that make sense? So if I can use any of those words interchangeably, and they all are just asking simply for the x-intercept, which is what we're learning how to find today. Yes? Okay, so knowing that, you can have 3 different amounts of solutions. So you can have no solutions. And if we're talking about x-intercepts, well, this is my x-axis. So if there's no solution, that means it does not touch my x-axis. So look, it did not touch my x-axis. Now I want you to realize it could have also opened downwards and be down here. Okay? But that's what no solution looks like. Okay, there could also be one solution. And that's what it looks like when your vertex is on the x-axis. So your vertex is just like either the highest or the lowest point of your parabola, your u. Okay? And there's only when it touches once. So that's what that would look like. It could also be opened upwards. And then the most common thing that you will see is 2 solutions. Okay, so 2 solutions is going to look like this. And see how it touches twice? So that's what 2 solutions would look like. So a key thing to remember is that we know quadratics are functions. So you might see it written like this. Okay, f of x equals ax squared plus bx plus c. That's just our quadratic standard form. Obviously there would be numbers instead of a, b, and c. But we could see it written like that. What does f of x mean? It's just y. It's just y equals. That's the same thing as saying y equals. Well, what did we say at the top that we want y to equal? 0. So we want all of our equations to be set equal to 0. That is our goal. So if you have an equation and it literally says y equals x squared by something, can you just put equals 0 on the other side? Yeah, because it didn't tell you what y is, and we want y to be 0, so you can just plug in 0, yes? However, here is a little different. This says x squared minus 4x equals 12. Well, let's look at it. A is here, B is here, and this is technically my C, but it's on the wrong side, so I need to move it over. And C goes where? Beginning, middle, or end? End. So I'm going to do minus 12, and I'm going to rewrite it. So I have x squared minus 4x minus 12 equals 0. Okay, and now I'm going to factor it. And then in a second, I'm going to show you there is a cheat method when A is 1, and I'll show you that. Yes, because 4x and x squared are not like terms, so I just had to put it at the end. But like when we get to number 4, you'll see like look 8 and 2 are like terms, so I'll show you what happens when it combines with something. But this one is your C. C always goes at the end, so we just left it at the end. So what does A equal here? B. Remember, A, B, and C are always numbers only. So what does A equal? Try again. 1. B.
-4.
And C.
-12.
There we go. And then A times C goes on the top of my X, so A times C is -12. And B is -4. So we need to figure out what multiplies to give me -12 and adds to give me -4.
Wait, since this is where we don't have to do the box?
We do not have to do the box because A is 1. You're exactly right. -6 and +2. And because A is 1, we don't actually have to keep going. We could be done. So what times what gives me x squared? Well, x times x, right? And then I could just bring over my split b. So -6 plus 2, and again, it still equals 0. So we're not done. This is where solving is different. Okay, so I know this is where I told you at the top, it says 0 factor property. This is what this means. Y'all, how do you get something to equal 0 when you're multiplying? By multiplying by 0, right? Because it cancels out. If 4 times 0 is what? 0. Okay, 0 times 6 is 0. 0 times 0 is 0. So if this equals 0, one of these or both of them has to equal 0. So how would we make them equal 0? Well, let's set them equal to 0 and find out. X minus 6 equals 0. X plus 2 equals 0. So we set our factors equal to 0 and we solve. So how do I solve this? There's an easy one step. Add 6 to both sides. And I get x equals 6. What about this one? Minus 2. And I get x equals -2. So you can leave it like that as x equals, or you can write it in the fancy brackets, or they're called braces technically, least to greatest, so -2 comma 6. Okay, however, if you use parentheses, I will take off points, and here's why. Because if you want to write it in parentheses, you have to write it as a point. And if you want to write it as a point, didn't we say y equals 0? So that would be -2 comma 0 and 6 comma 0. Do you see what I'm saying? So this, and this are all three the same thing. I'm always going to write it like this, but if you just wanted to stop at x equals 6, as long as you box both of them, I do not care. Does that make sense? I always put at least to greatest. That's the proper way. I won't take off if you don't, but I will take off if you use parentheses instead of fancy brackets. There was no GCF.
Well, are we doing that?
Yeah.
Okay.
So here, I want you to realize what we're saying is that if we were to graph this, it is touching at -2 and +6. So like that's approximately -2 and +6. That's all we're saying. Those are my solutions. Now, here's my thing, is if they're pretty numbers, could I have typed that in the calculator and found it in the calculator? And guess what? Every time A is 1, guess what's going to happen? They're going to be pretty numbers. So I'm going to show you how every time A is 1, you can type these in your calculator. So you go to y equals, they have to be equal to 0 first, yes? So I got it equal to 0, and I'm just going to type this left side, so my equation, not the equal 0, because that's what we're finding. So x squared minus 4x minus 12. Everybody okay with that? And then I go to my, well, I'm going to hit graph first, and here's why. A lot of times, and I've seen this mistake today already, is people will come to me and be like, oh, this one only had one solution. And I'm like, no, it didn't. And it's because when they go to the table, they see one solution, they write down the one solution, and then they say they're done. How many times did it touch? So how many solutions do I need to find? 2. So watch when I go to my table. How many do I see? Well, I'm looking for where what is 0. I'm looking for where y is 0. So my y, here's y is 0. What's my answer? Did I get that? So now I need to find the other one because I saw that it touched twice, right? So scroll the other way because I also saw that it was on the negative side, and there's my other one. Did I just find my two answers? So did I have to do any of that work? No. That only works when a is what? 1. Okay, because when a is not 1, you'll see why, and I'll show you. Like on 3, one of your answers is a pretty number. So you could find half of your answer, but is that really going to help you in the end? No, you still have to find both your answers, so you still have to factor it. Okay, but let's look at number 2. Well, what's wrong with number 2 first? Is it equal to 0 yet? No, so this one's in a super weird order. A is here. What's this? That's my C. And what's this one on the other side? B. And I know that because it has an X behind it. I know this is my C because it has no letter behind it, right? So when I move this 6x to the other side, I'm going to do minus 6x. I need to put it in the middle. So minus 6x. I'm just going to kind of squeeze it right there so I know where to put it. It has no like terms, so when I rewrite it, I get x squared minus 6x plus 9 equals 0 because it's my B term. And it goes A, B, C. Right? Highest degree to lowest degree. X squared is 2, 1, 0. So now, I know I can do this in my calculator because A is what? 1. So I'm going to come here. I'm going to type it in. I have x squared minus 6x plus 9. I'm going to hit graph. How many times does it touch? Once. So how many answers am I looking for? 1. So second graph. And I'm looking in the y column. Be careful. Do not look in the x column. There will always be a 0 there. Okay, that's not the one you're looking for. You're looking for this one. So what's my answer? 3. There we go. That's it. Now, again, the sad thing is that only works when A is 1. However, on your practice, there are quite a few where A is 1. There are also quite a few where if you take out the GCF, guess what A becomes? 1. So is it important to pay attention to GCFs? Yes. Okay, so that's when A is 1. So let's look at when A is not. Okay, it's a little more work. I'm sorry, but it is what it is. So let's look at number 3. Might help if you can see it. Okay, so here, it doesn't have a GCF. No. It's already set equal to 0, so we're good there. So we're just going to get started. So we're going to find our A, B, C. I'm just going to kind of set it up. Okay, what does my A equal? Oh, you're good. Story of its life. 2. You're fine. Oh, did it fall on you? B.
5.
And C.
-3.
Okay, and then what's A times C?
-5.
Multiply. -6.
-6, -6.
And B is 5. So what multiplies to give you -6 but adds to give you 5?
6, -1.
Yep, positive 6, -1. So just a reminder, first term goes in your first box, last term in your last box, and then this is my split B. So positive 6, -1, and then don't forget your x's. And now it's just GCF. So I always start with my smallest number. Does 2 go into 6?
Mm-hmm.
So that's my GCF. Do they both have an x? Then I have to take out an x. Smallest number is 1. Does 1 go into 3? Yes. And it's negative, so I have to take out a negative. Everybody okay with that? Okay, here, smallest number is 1. Does 1 go into 2? Yes. And they both have an x, so I take out an x. Smallest number is 3. Does 3 go into 6? And that was a positive 6, so this is positive.
Couldn't the word x just be x?
Yeah. If you just put x, and I'm going to rewrite it as just x. So I have the factors of 2x minus 1, x plus 3 equals 0. And I'm going to split up and solve. Lauren, don't fall asleep. Okay, so I have 2x minus 1 equals 0. And then I have x plus 3 equals 0. So the plus 3 is going to be my simple one to solve. I'm going to do minus 3 on both sides, and I get x equals negative 3. The other one's still simple, but it's 2-step versus 1-step. So what do I do first? Plus 1 on both sides. And I get 2x equals 1. Now what? Divide by 2. So I get a half. So my answer is negative 3 comma a half. So it's more work to get there, but it's doable. Any questions with that one? I'm going to leave it there for y'all to finish copying. And then we're going to look at number 4. Okay, so here I have A, B, C, and then I have the 8 on the other side. Well, what is that 8 going to join?
The 2?
Yeah, the 2, so it's a part of your C. So what am I going to do to move the 8?
Minus 8.
Minus 8. Minus 8. Minus 8. That's its like term, so that's where I'm going to line it up. And I'm going to bring down my 12x squared minus 14x. And what's negative 2 minus 8? Negative 10. Okay, so now, does it have a GCF? Yes, what's my GCF? 2. So I'm going to take that 2 out. So I'm going to divide by 2. And I'm left with 6x squared minus 7x minus 5 equals 0. Okay, so we're going to kind of ignore our GCF for a second. And what is my A? And what's my B? And what's my C? I wasn't sure if you were alive right there. Okay, so what's A times C? Negative 30. And B is negative 7. So what multiplies to give you negative 30 but adds to give you negative 7? Negative 10, positive 3. Now, one thing I want you to pay attention to, which I saw lots of mistakes with last week, not lots, but it was a common mistake, is when you're filling in that first term, people were going back to the original. Okay, do not go back to the original. We took out the GCF, so we should be going about here. So if you need to squiggle it out, squiggle it out. So we're looking at the 6x squared as my first term, minus 5 is my last term. Here's my split B. Now, what's my GCF between 6 and 10? 2. And they have an x in common, so 2x. What's my GCF between 3 and 5? 1. And it's positive, so plus 1. Here my smaller number is 3. Does 3 go into 6? Yes. So this is my GCF of 3x. And what's my smaller number is 5. Does 5 go into 10? So my GCF is negative 5 because it's touching a negative. So I'm going to bring that over here with my my original GCF. So 2x plus 1 and 3x minus 5. Now, what I want you to realize is you technically have 1, 2, 3 factors. But if I set that 2 equal to 0, does that give me anything? Does 2 equal 0? No, so this is a waste. However, what if my GCF was an x and I said x equals 0? Does that give me something? Yes. So just know that the only time your GCF is really going to give you something is if it's a letter, okay? Which we'll work with on Wednesday more so than today. So today we're really just dealing with quadratics, so you're not going to see that. But here we have the 2x plus 1 equals 0, and then the 3x minus 5 equals 0. So minus 1, 2x equals negative 1. Divide by 2, and I get negative a half. Here we do plus 5 plus 5. 3x equals 5. Divide by 3. And there's my answer. No, because it didn't, if you set 2 equal to 0, that didn't give me anything. Now, on this last one, I'm going to scribble it out. We're going to do a different problem. Because I don't know why I gave y'all one that wasn't a quadratic when I literally said these are quadratics. So, we're going to do this. Well, first off, what do we need it to equal? 0. So I need to do what? So one thing I want you to realize, do we ever want a to be negative? No. So pretty much I personally will do everything. I will move 2 terms to keep a positive before I move 1 term to make a negative. Does that make sense? I'll show you on the practice in a second. But I'm going to do minus 9 versus minus 4x squared because I don't want to make a negative and then have to take an a out. That's why I give myself more work. So now I have 4x squared minus 9 equals 0. Well, I could do a, b, and c. B would be 0. But what else could I do here? It's a perfect square minus a perfect square, right? What squared minus what squared? Remember, we have a minus b, a plus b for this formula. So what squared gives me 4x squared? 2x. And what squared gives me 9? So I have 2x minus 3, 2x plus 3. And now I can separate and solve. So plus 3 plus 3. Now the nice thing on these is your answers are almost always, if not always, going to be the same except one negative, one positive. Any questions with that? So there's a couple things I want to show you on your practice of what I was talking about. First off, do you see on the front how many of them have a as 1? Number 1 has a as 1, number 2, number 3, number 4, number 7. Okay, there's another one on there that if you take out the GCF, a becomes 1. So can you do all of those in your calculator?
Yes.
Yes. Okay, that's 6 out of 9 on the front. There's only 6 on the back. Actually 5 because I took one off. Look at number 6. I'm not going to do it with you, but I want to show you something. We don't want a to be negative, right? So can we move a to the right versus moving these to the left, and that would make a positive? So let's do that. So if I add 2x squared to both sides, now I have 0 equals 2x squared minus 5x plus 2. Do you think it matters which side is 0? No. If you don't like 0 on the left, could you rewrite it as equals 0 on the right? Yes. It does not matter which side your equal sign is on. Okay? So now you have a as positive and you don't have to take out a negative. And you moved less. Does that make sense? Okay, also, the confusing part about our little surgery we just did on the packet, the back is Wednesday's notes. There's another copy of it, so don't stress about that. This is the back of your practice. Yes? Okay. So it's like almost front side is your practice. Yes? 1 through 15. Okay, this is what you're working on.